Hi to everyone. In this video, let us discuss regarding Gibbs free energy. So, what is the Gibbs free energy and what is the need to introduce Gibbs free energy into the thermodynamics that topics. Now, what is that introduction need here? See here. If you consider delta S and delta H values, if delta S is positive, delta H is negative, the reaction is said to be spontaneous. The reaction is said to be spontaneous. Why for delta H? Why that delta H negative is here mandatory condition means delta H negative means that system is losing some heat energy. Losing some heat energy means there is a decrease in that net energy. That means less energy of a system will play the important role to get the stability. So that's why only as heat energy in that means loses, that will get the stability. And here this is which one, delta S is positive. These reactions also considered as which one, spontaneous. But here one important point here, what is that, if you consider some reactions, example here, evaporation of water, evaporation of water from a pond or a lake, you can observe that that process takes place spontaneously. But for evaporation of water, delta H is not negative, delta H is positive. So even the delta H value positive, this reaction is taking place spontaneously. So this process is indicating what here? Delta H negative for spontaneity is not a sole criterion or not a necessary condition. And also another one here, decomposition of solid NH4Cl. Decomposition of solid NH4Cl into NH3 and HCl. This is also takes place spontaneously at room temperature conditions. But that is also having which one, delta H value positive. Even though delta H value positive, these reactions are taking place spontaneously. That factor indicates that delta H negative for a spontaneity is not a necessary condition or not a mandatory condition. And also now come to this one, delta S positive. So if you consider delta S positive is the necessary condition for spontaneity, means it is not correct in all cases. Example, liquefaction of gases. In the liquefaction of gases, gas converts into liquid state. That means what is happening here? That entropy of that which one, that substance decreases when that liquefied from a gaseous state. Even though entropy value decreases means delta S is negative. Even though delta S is negative, that process also taking place spontaneously. That means here delta S positive for spontaneity is not a mandatory condition or not a necessary condition. So overall or finally what we have to say here, delta H negative, delta S positive, these are not sole criterion for the spontaneity of a reaction. That means these are not necessary conditions for spontaneity of a reaction. Just they are required conditions, because even with delta H positive or even with delta S negative, many reactions or many process we are observing, they are occurring spontaneously. That means delta H negative, delta S positive are just required conditions for a spontaneity, not necessary conditions. So first you should understand what is the difference between required condition and necessary condition. So for example, if you consider 25 years that one person, 25 years one human being. Now daily drinking milk with Boost or Bornavita or Horlicks is not that means not a necessary condition, just that is a required condition. Whether that person drink or doesn't drink that Boost or whatever it may be, no problem. If drink means somewhat better, that's only. That means drinking Horlicks or drinking milk daily for a 25 years person is not a mandatory or not a necessary condition, just that is a required condition. But for the same person, inhaling oxygen is necessary condition. Without oxygen, that person may not without breathing may not live. That means here that is the difference between necessary and required conditions. So like that here, delta H negative, delta S positive are just required conditions but not necessary conditions for a spontaneity of reaction. So we are unable to determine spontaneity of the reaction just by considering delta H or delta S individually, because some reactions are taking place spontaneously even with delta H positive and even with delta S negative. That means we need some other that means some other which one factor or some other any one property which can determine the spontaneity of a reaction. We need any other some other extra one here to determine the exactly whether the reaction is spontaneous or not, because these two are not necessary conditions and we can't depend on them to determine the spontaneity of a reaction. So that's why they introduced another factor, that is nothing but which one gives free energy to determine the spontaneity of a process or spontaneity of a reaction. Now here from that above examples what we understood means here delta H negative or delta S positive alone, those if you consider we are unable to determine. But in some cases if you observe that what is here evaporation of water, here in this case delta H is positive but delta S also positive. Now here in some other cases, that means here what we have to understand here, not only the delta H, we have to observe here delta S. That means a combination of delta H and delta S will give the perfect solution for that spontaneity, because in some cases delta H positive but the reaction is spontaneous because delta S is positive. In some other reactions, if delta S is negative, even though reaction is spontaneous because at that time delta H is negative. That means to determine exactly whether the process is spontaneous or not, we need the combination of both enthalpy change and entropy change. So now here Gibbs free energy is introduced by the combination of these two factors. Now change in Gibbs free energy delta G equals to delta H minus T delta S. Now let us see what is Gibbs free energy here. What is Gibbs free energy change means? The energy present in a system to do the useful work, that is known as Gibbs free energy. The energy present in a system to do the useful work is known as Gibbs free energy. That delta G is calculated as delta H minus T delta S. That means here spontaneity is depends on which one here, temperature factor also. Let us see what is the effect of temperature on spontaneity. And here for any reaction, if delta G is negative, that reaction is said to be 100% spontaneous, and delta G negative is a necessary condition for spontaneity, not required. It is necessary condition. And if delta G is positive, the reaction is said to be 100% non-spontaneous, no doubt at all. And if delta G value is 0, that reaction is said to be present at equilibrium. So like that here, to overcome that problem, to determine the spontaneity, Gibbs free energy helps a lot. Like that, if Gibbs free energy change is negative, the reaction is said to be spontaneous. If that delta Z value is positive, the reaction is said to be non-spontaneous. If delta G value is 0, the reaction is said to be present at equilibrium. Okay, now let us see what is the effect of temperature on spontaneity of a process. So for that, we have to write these three, which one, that thermodynamic properties. What are those here? Delta H, and here delta S and delta G. So these three factors we have to write here. Now here we have to write which one, what is that nature of the process, spontaneous or non-spontaneous. Now first, spontaneous at all temperatures. So if a process is spontaneous at all temperatures, delta G is nothing but which one, negative, delta S positive, delta H is negative. And second one, non-spontaneous at all temperatures, means exactly opposite to the first one. Here plus, minus and plus. And third one is here spontaneous at low temperature. Spontaneous at low temperature means delta G is negative. Now come to the delta H. Even at low temperatures, the reaction taking place spontaneously means that must be exothermic reaction. So exothermic reaction means delta H is negative and delta S also negative for this, which one, spontaneity at low temperature. Okay, then non-spontaneous at low temperatures means this is positive. And now come to the delta H here. At low temperature, the reaction is not spontaneous means that must be endothermic reaction. Endothermic means here we have to write plus and this one also plus. Okay, then after that, come to another factor here, spontaneous at high temperatures. Spontaneous means we have to write a negative sign for delta G, and spontaneous at high temperatures means that reaction need high temperature, means that must be endothermic reaction. So now this is plus, this one also plus. And non-spontaneous at high temperatures means here positive, negative, negative. So remember one thing here, for the first two conditions, delta H, delta S signs are opposite. But in remaining all cases, just we have to determine the sign of delta H using that effect of temperature, and give the same sign for the delta S also. To remember, this is one easy technique. So this is the effect of temperature on which one means that spontaneity of a reaction. Now some important relations are there for which one gives free energy change and E naught cell. That means electrode potential, or E naught cell means E naught value of galvanic cell. So now what is that means here? Delta G naught equals to minus NF E naught cell. Delta Z naught equals to minus NF E naught cell. If E naught cell is positive, positive into negative, that will become negative. So then delta Z naught negative means the reaction is spontaneous. And at equilibrium state, what is that delta G? Okay, delta, what we have to write here? Delta G equals to, or delta Z naught equals to, what we have to write here? Minus 2.303 RT log K. Okay, delta G equals to minus 2.303 RT log K. They give that log, that means K value, equilibrium constant value. We have to determine which one means a change in Gibbs free energy by using this formula minus 2.303 RT log K. Okay, now this is regarding which one gives free energy change. Okay, then after that, next one is here, which one? Thermodynamics third law. So what is third law of thermodynamics? Third law. Thermodynamics third law means one important thing here. This thermodynamics third law doesn't give any new concept. Just that will give the limitations on known concept. So what is that law here? According to thermodynamics third law, entropy of a perfectly crystalline substance is equal to 0 at absolute 0 temperature. What is that here? Entropy of a perfectly crystalline substance is 0 at absolute 0 temperature. So ST tends to 0 equals to 0. Or another one here, S can be calculated like this here. What is that? Integral 0 to T. We can write which one here? CV by T into dt. So this is the equation to calculate which one? That absolute entropy. So now according to thermodynamics third law, what is that? Entropy of a perfectly crystalline substance at absolute 0 is equal to which one means 0. That means just it is giving a limitation on known concept but not giving any other new concept. So this is regarding which one means that thermodynamics third law. Okay, bye.